Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Today our topic is transition metal. So my name is Ismail Hakim bin Mapisol, and we will present about transition metal. Before we start, I would like to introduce our presenters. First, we have Muhammad Amar Hakimi bin Muhammad Muhammad Ifat bin Hanafiah, Muhammad Ahmad Zakawi bin Al-Ruzuliman, and Muhammad Amar Hazid bin Abu Bakar. Have a three objectives that will be discussed today. First, to explain the characteristic properties of transition metals, to identify the transition metals, position in periodic table, to discuss the important and application of transition metal in industry and daily life. First, what is transition metal? Transition metal constitute a series of elements mainly found in group 3 until group 12 in of the periodic table. Transition metals are also oftentimes called as d block element. The characteristic trait involving the presence of partially filled d orbital in their natural atom or in their usual oxidation states define the element in the d block as transition metal. The presence of this trait allows the element to display different characteristics such as the ability to produce ion, catalyzers, or color substance. Transition metal. What are different for each metal? From the definition, metal is elements that are typically solid, shiny, malleable, and good conductors of heat and electricity. Meanwhile, transition metal is a d block elements with incompletely filled d orbital, their atom or ion. For location on periodic table, metals are mainly positioned on the left side of the periodic table. Transition metal occupy the central section in periodic table. For example, metal we have calcium, magnesium, and sodium. Transition metal we have iron, manganese, and vanadium. We will discuss about the characteristic of transition metal, where they are in periodic table, and the application in our life.
For transition metal position in the periodic table, the transition metals position in group 3 until 12 in the periodic table and are generally characterized by partially filled d subshells in the free elements or their cation. The example for transition metals is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc, and others. For example of valence electron configuration for scandium 4s2 3d1, titanium 4s2 3d2, and increase by the increase of groups.
Moving on to the special characteristic properties of transition metal, we will be looking at the formation of colored compound. Each transition metal has a unique arrangement of d electron. When exposed to light, the transition metal complex will undergo excitation of electron from lower energy d orbital to a higher state called d and d transition. This transition will create an energy gap as the electron move from the lower state to an upper state that will determine the type of light that is absorbed by the compound, leaving complementary color that is reflected back to be seen by our eyes. As we can see in the chart in the middle, if we assume that the color the compound absorbs is orange, which is between 590 nanometer to 630 nanometer wavelength, the color that we will be seeing on the compound will be blue, and vice versa. Now, there are several factors that can influence the formation of colored compound. The first is the oxidation state. The oxidation state affects the number of filled d orbital of the transitional metal, which can produce different color even for the same metal. This we can see here in the figure. For vanadium, if the oxidation number is 2 plus, it will show the color purple. But for the vanadium, when its oxidation number is 3 plus, it will show the color green. Second, if the transition metal have a strong field ligand, it will have a large energy gap for the D and D transition. This will cause it to absorb light with higher energy and shorter wavelength. Example of ligand that have strong field ligand are cyanide ion and carbon monoxide. If the transition metal is with weak field ligand, it will have a small energy gap. This will cause it to absorb light with lower energy and longer wavelength. Example of ligand with this characteristic is bromide ion and chloride ion. The second special characteristic properties of transitional metal is its catalytic properties. Catalysts are substances that can alter the rate of chemical reaction without affecting the result of said reaction. Transitional metal contain presence of vacant d orbital. Transition metal will form an intermediate complexes with their reactant, which will provide an alternative path by lowering the activation energy for the chemical reaction. When the chemical reaction have completed, this complex will decompose later, returning to its original state, allowing the catalyst to be used again. Furthermore, the catalyst also provide free vacancy for the reactant molecule to get absorbed on the surface, which will create a large surface area that can increase the rate of reaction.
For the third characteristic properties of transition metals, and that is variable oxidation state. In a transition metal atom, once the 3D subshell is occupied with electrons, the electrons in the 4s subshells increase to a higher energy, and then the 4s subshells electrons are lost first when transition metals atom reacts, and the transition metals usually show a +2 oxidation state from losing 4s electron, but loss of 3D electrons give them variable oxidation state, with the maximum involving all 4s and 3D electron. And we can see that from the table of oxidation state in period 4, we can see some example of oxidation state from Ti, vanadium, chromium, manganese, iron and others.
Special characteristic properties of transition metal. For complex ion, the first one is compound color. Usually show bright colors due to electronic transition between the orbital of transition metal. This energy promotes electron from a lower energy d orbital to a higher energy d orbital. The second one is magnetic properties. For magnetic properties, complex ion may be paramagnetic or dimagnetic depending on whether the central metal ion has unpaired electron or not. As we know, ion with unpaired electron are known as paramagnetic, while ion with all electron paired are known as dimagnetic. The third one is shape. Complex ion usually have fixed coordination numbers that determine their shape, such as octahedral, tetrahedral, or square planar. The last one is stability. Its stability depends on the strength of the metal and ligand bond, which may change the color or stability of the complex. Some complexes are very stable due to the strong bonds of metal and ligands.
Now we talk about the important and application of transition metal in industry and daily life. For the first one is daily life application. There's biologies, pigment, dyes, medical and everyday product. For the biologies, iron in hemoglobin for oxygen transport. For the second one is pigment and dyes, cobalt, chromium and cadmium compound create vibrance, color in paint, jewelry and gemstone. For the third one is medical, titanium for implant, platinum is some cancer treatment, and also iron in herb supplement. For the last one is everyday product, zinc in sunblock, titanium dioxide in paint and toothpaste, also plastic. For the second type is industry and application, construction in infrastructure, iron and steel for building and vehicle, titanium for strong and lightweight aerospace part. The next one is electronic, copper for wiring, gold for corrosion resistant connector, alloy, nickel and chromium create stainless steel, and also dual for energy, nickel and cobalt in batteries, transition metal in solar cell.
In conclusion, transition metal are an important group of elements with distinctive characteristics that set them apart from other metals. They occupy a specific position in the periodic table and contribute significantly to chemical reaction and material properties. Transition metals are widely used in various industries and play a crucial role in technology, manufacturing and daily life. Their versatility and usefulness make them essential in supporting modern development and improving the quality of life.
These are the references that we use in making this video. This is the continuation list of the references that we use in this video. That's all from us. Thank you for listening.